Hi guys, so what we're going to talk about today is we're going to talk about congruent chords and arcs, and there's a couple things that we have to know before we do this, so we're going to go through these notes right here. So it says two chords are congruent if and only if, so that means these things have to be true in order for their chords to be congruent. Their corresponding arcs are congruent. So if chords are congruent, then their corresponding arcs are also congruent. And then what that means is that if AB, this chord right here, is equal to CD, this chord, then that means their arcs, AB, has to be congruent to the arc CD, the measure. Okay, and then if two chords are congruent, then they are also equidistant from the center. So that means if AB is equal to CD, these two chords, then that means they're equidistant from the center. So this EF is congruent to EG. So these little parts are going to be congruent. They're equidistant from the center. And then if a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. So if EH right here is perpendicular to AB, which it is because you have a 90-degree angle, then what that means is it splits this chord into two equal pieces. So AF is equal to BF, and then it also splits the arc into two pieces. So AH is congruent to BH right here, the measures of those two arcs. So that's all the information we're going to use to do these problems. And I'm just going to walk you guys through some. So we're just going to find the value in this one. So it says find the indicated value. So what we see at the moment is you have two chords that are congruent to each other. And so what that means is that these two arcs also have to be congruent to each other. So what you're going to do is you're just going to take those two values and set them equal to each other. So this 7x plus 24 has to equal 115 degrees. And then you're just going to solve it algebraically. And then you're going to get x is equal to 13 at the bottom down here. Okay, so the fact that the chords were congruent, that means their arcs also have to be congruent. All right, in this one, we're going to find x as well. And all this does is reverse it. So it tells us the arcs are congruent. So that means these chords have to be congruent. So you're going to set 18x minus 2 equal to 52. Solve it algebraically. So 18x equals 54. Divide by 18. X is going to be 3 for this one. Okay, so I hope that's really straightforward. We're going to skip that one because it's really similar. And then this one, it wants us to find the measure of RS. So it's taking it just one step further. So you have these two chords that are congruent. So that means that their two arcs have to be congruent. So your first step is making this 11x minus 72 equal to the 5x plus 6. Then you just do some algebra. So cancel, and then you got 6x equals 78. Divide by 6, so x is going to be 13. And then this problem did ask us to take it a step further and asked for x equal to 13. So what you're going to do is you're going to plug that in, or sorry, they asked for the measure of the arc RS. You're going to go and you're going to plug it into this equation. So the measure of RS is equal to 11 times 13 minus 72, which is 71 degrees. And then that's going to be your final answer. So just be careful, pay attention if they ask for x or if they want you to take it a little bit further. Okay, and this one I just want to set it up and we don't have to solve it all the way down. So here's what I see. I see these two chords are congruent because they have the little tick marks on them. So that means these two arcs have to be the same. And then they give us that this is 76, and I'm just trying to solve for x. So I can see that I really could make this whole circle into an equation. So I know that there's really going to be two of the 6x minus 20s because those two arcs right here are congruent. And then I also have a plus 76. Now that includes the entire circle. So I'm just going to set this up equal to 360, then you distribute, and then you guys know how to do all this algebra. So you'd solve this all the way down and you get x equals 27. So there's lots of ways to keep going with this. This one was using the whole circle, but you started with knowing that your chords were congruent. Okay, so this one, it says find MP. So we're looking for this little length right here. Or no, if MP equals 5x minus 34 and PN equals 2x minus 4, find MP. So this is one of those rules where it says if these radius are perpendicular to the chords, then that means that they're equidistant from the center. So that means that these two lengths have to be equal to each other. So in order to solve this problem, you just take 5x minus 34 and set it equal to 2x minus 4. And then you do some algebra. So you got 3x equals 30, so then x equals 10. And then this one wanted you to find MP, so then you just plug it back into this equation right here. So 5 times 10 minus 34, you'll get MP equals 16. So the fact that these were perpendicular to the chords and that these were the same, we know that this distance is going to be congruent. Okay, in this one, they give us DE. So this entire chord is this, and they give us FG, this entire chord is this. So in this one, you can see that the distance from the center is the same and they're perpendicular. So that does tell us that these two chords are equal. So you're able to just take 11x plus 15, set it equal to 32x minus 27, do some lovely algebra. So you get x equals 2. And then in this one, they did want you to find DE, so you just plug it back into there. So 11 times 2 plus 15, so you'll get DE is equal to 37. And then you're done. Okay, this one we're just going to set up because it is just a little bit different, but it's the same idea. So you have your two radii are perpendicular to these chords. They also are equal, they're congruent. So that tells us that these chords are congruent, which means that these arcs also have to be congruent. So on this one, you would just set up 9x minus 43 equals 5x plus 33. And then you just do your algebra and solve. And this guy should end up being 104 degrees when you solve fully for MP. So that hopefully makes sense. And then we're going to go through these that take it a little bit further. So it says in the circle Z, if RS is 18, so this whole entire chord is 18, and the measure of arc TY, so this arc right here is 42 degrees. We want to find each of the measures that are listed over there. So let's start with what we know. So we want to find TV. So I do know that these are equidistant from the center, so that means these chords have to be congruent. So that means if RS is 18, that means all of this TU has to be 18. So I can fill that one in. That has to be 18. And then I know that since this is congruent and perpendicular, it splits this entire arc and chord in half. So if this entire thing was 18, then this distance from T to V right here is going to be half of that, which is just going to be 9. Okay, and then WS is the same thing. So this is congruent these are congruent and perpendicular. So that means it cuts this in half. Whole thing was 18. So WS also has to be 9 because it's just halfway. And then you want to find the length of YU. So we do know that this is cutting not only the chord in half, but also the arc in half. So that means that this measure of this arc has to be the same as this one right here. So this has to be 42 degrees. And then you want the measure of RS. Well, you know these arcs are congruent. So you just do 42 plus 42, and you get that this is 84 degrees. Okay, so let's do a different one. What do they give us in this one? In circle I, BG is 17. So this little part is 17. It is a 90-degree angle right here. And then it gives you the measure of CHA, arc CHA, so this whole thing, is 256 degrees. And we want to find each measure. So let's see, they want us to find the whole entire BC. Well, it looks like these are congruent and they hit at 90 degrees. So we know that that cuts the chord and the arc in half. So if this part is 17, then to get the entire BC, we would just do 17 times 2, and this would give us 34 degrees for that. So this was just 17 times 2. And then we want FB. So we know that this also has to be congruent to BG because they're cutting each of these congruent chords in half. So this has to be 17 degrees. And then they want the arc of A to B right here. So what you need to do for this one is, let's see, what do we know so far? CHA, okay, so we know that these two chords, so let me do these in different color, that this arc and this arc are gonna be the same, and you know the rest of the circle is 256. So if you wanna figure out which is one of these arcs are, which is AB, which is what we're looking for here, you're gonna start by doing 360 minus the 256, and we will get that to be 104. And so then that's telling me all of this is 104 degrees, but I want just one of them. We know they're congruent, so I can cut it in half, divide by 2, and I'll get that this is 52 degrees. And then I know the same thing for BC, because that's going to be a congruent arc. This also has to be 52 degrees. And then EC is just going to be half of that, because you know that this is cutting that chord or that arc perfectly in half. So then you would just take 52 divided by 2 for this, you get this to be 26 degrees. Awesome. Okay, so same thing, but we're getting some equations here. So we've got QM is equal to the 6x minus 11, and we've got MR is equal to this. Now, what do we have here? So we have these two radius are perpendicular and they're the same distance from the center, so that means that this arc and chord are being cut in half, and that's saying that if they're being cut in half and that they're congruent, that means that my two lines here have to be equal. So what you're going to do is you're going to take 6x minus 11, and you're going to set it equal to 2x plus 9, do your algebra, listen to my dog chew her bone. So you get x is equal to 5, and then they did want you to take this and solve for mn. So you're just going to plug it in for, let's see, mn is this whole length. So I'm going to find mr and I'm going to double it. So I'm going to plug it into this equation. So 2 times 5 plus 9 is going to be 19. So then to get all of mn, you're just going to take 19 times 2, and you'll get that that length is 38. And then that's going to be your final answer for that one. Okay, the measure of arc CI, so this arc is 7x minus 15 degrees. The measure of arc EF, so this entire thing is this, and you want to find the measure of CI, so you're going to find this. Okay, so let's determine the relationship we've got. So they're the same distance from the center, they are perpendicular, so that means my chords and my arcs are congruent, and it also means that these radii are cutting the chords and the arcs in half. So what that tells me is that if I take this purple arc, this EF, and I divide it by 2, then it should be the same amount as CI. Or you could do it reverse. You could take this CI and double it and make it equal to this. But I like making my numbers smaller. So I'm going to take measure of EF and I'm going to divide it by 2. So 12x minus 8, I'm going to divide all of that by 2, so this becomes 6x minus 4. And then I know that has to be equal to the pink arc. So I now know 7x minus 15 is going to equal 6x minus 4. Do your lovely algebra. So you get x is equal to 11 in this case, and then they just wanted you to find CI, so you go back up to this equation and plug it in. So measure of arc CI is equal to 7 times 11 minus 15. Do the math, and that should be 62 degrees is going to be the measure of that final arc. So I hope this is making sense. And then these ones down here, you're going to need a calculator because it is a little bit strange. So we're going to do these ones together. So for 13 and 14 here, we're going to use this circle. And we're going to find VW for this first one. So we're looking for VW. So we want this entire length right here for the first one. So what I see is I could probably find this length of that triangle, and then I'm just going to double it because I know that this is perpendicular, so it's cutting that perfectly in half. So what do you have at the moment? Well, you have a right triangle there where you have this is 5, this is 13, this is a 90 degree. So you can find that x by just doing the Pythagorean theorem. So x squared plus 5 squared equals 13 squared. So then you've got this is 13 squared minus 5 squared, do your square root. And then you guys should hopefully know how to plug that in, but let's just do it. 13 squared is 169, 5 squared is 25. If I do 169 minus 25, it's 144. So then you're gonna get x is equal to 12. So that means this little part is 12. So then to get the entire VW, I double it. So 2 times 12, which is going to be 24, is going to be your final answer for that one. So now we're using right triangle stuff and hopefully bringing back a little bit of your trig stuff that you remember. Okay, so let's see. Now we need the measure of arc YW. So this is a central angle. So I know if I can find this inside angle right here, this arc is going to have the same measure of it because it's a central angle. So let's redraw what we have here. So we've got this is 5, this is my 90, this is 13, and we now have this is 12. And then this theta is going to be my central angle. So what we're going to do is we're going to set up a Sohcahtoa. So let's see. This is opposite, and this is adjacent. You could use anything you want, but I'm going to use tangent. So we'll say tangent of that angle is opposite over adjacent. And then remember to get the theta or the angle out of here, you do the inverse tangent of both sides. So then they're gonna inverse tangent and tangent cancel over here. So then you're left with just theta on that side equals the inverse tangent of 12 over 5. And then what you're gonna do is you're gonna go plug this into your calculator. So let me move this over here. So remember, there's a couple things you have to check. Your first thing you have to do is you have to go to mode and make sure that yours is in degrees, which mine is not. So you're gonna go down here, click it, enter, now it's in degrees. Then I go second mode and I quit. And then I'm gonna go to the inverse tangent. So I click second tangent and then just type in 12 divided by 5. And I get that that angle is 67.38 degrees. And so then that helps me with this problem, because if I move this back over here, we know that this angle inside of here now is the 67.38, and that's equal to this arc measure because central angle is equal to the arc. So then you say measure of arc YW is equal to 67.38 degrees, and then you're done. Okay, so don't forget your trig because it does come into really important play here. All right, last two questions, then you guys are gonna go do some practice. So use the circle below for question 15 and 16. So it tells us HK, so this entire HK is 30, and it tells us that PM, this distance right here, is just 8. And it wants us to find PH. So we're looking for this one for the first problem. Okay, so let's label everything that we've got. So we know this pink line is 30. We can see that these radius are perpendicular to the chords. They're also equidistant from the center. So that means that the chord and the arcs are getting cut in half. So if this chord is 30 and it's getting cut in half, that means this is 15. And that also means that this length has to be 15 because they're going to be congruent. So if I cut them in half, they're the same. And then it gives me that this length is 8. So let me redraw this triangle that we have here. Make this my 90 degree. So you have this side is 15. You have this bottom side is 8 because it's down here. And what we're looking for is the PH, which in my problem is going to be this one. And it is a right triangle. We do have two sides. So you're going to do the Pythagorean Theorem again. The x is going to be the thing that's all by itself because it's across from the 90. So x squared equals 8 squared plus 15 squared. If I do 8 squared plus 15 squared, that becomes 289. Take a square root, you get x is equal to 17. So then that means PH is equal to 17. So this length inside of here is a length of 17. Okay, last problem. We want to know G, the measure of arc GJ. So all the way around here. So what I notice is I can find half of this arc by finding this central angle right here. And then I can double it to get the entire GJ. So let me see if I can draw this right triangle again. Not very well, but this was 15, this was 8, and this we now said was 17. And what we're looking for is this central angle right here, which is representative of just this tiny angle right here. Okay, so you're gonna have to do some inverse trig again. Let's do tangent again. So this is opposite, this is adjacent. So I'm gonna say tangent of theta is 15 over 8. Then you do the inverse tangent. Both sides. On this side, these will cancel, so you'll be left with theta equals the inverse tangent of 15 over 8. And then we just plug that in. So second tangent, 15 divided by 8. And we get 61.93, we'll say. Okay, and then that only gave us half of the arc. So if we come back over here, that only gave us that this part GH was 61.93. So if I want the entire GJ, I'm gonna double that. So the measure of arc GJ is 261.93. And if we do that in our calculators, it becomes 123.86 degrees. And then that's gonna be your final answer. So don't forget the things that we learned about circles on the last time. If you have a central angle, your arc is equal to that as well. But there's a lot of loaded information in here. So what you guys are now gonna go do is you're gonna go do homework number 6. Make sure you're checking your answers and reaching out for help if you need it. As always, I hope you guys are doing great, and I really do miss you.